This is going to be the start of a new project where I'm going to try and build the QuadTree data structure completely from scratch in C++. We're going to try to avoid the use of any major external libraries that allows us to do this and try to build everything kind of sandboxed. So for those of you who are new to this, a QuadTree is a spatial data structure that allows you to kind of hierarchically store information or data. In this case, I'm mostly going to be looking at point data, so any sort of object with an X and Y location. Um, and if you have lots of these points and you're trying to calculate interactions between these many points, it gets very expensive and the number of points gets very high. A quad-tree data structure is essentially a way to figure out how close each of these points are with relative to each other and kind of help you optimize the number of interactions that you have. So essentially, you take one big domain, so this full blue box over here, you insert a bunch of points, and if that number of points is more than a maximum allowed number of points in the tree, it'll subdivide into 4 quadrants, and that's why it's a quad tree. In 2D, it divides into 4 quadrants, and you recursively subdivide until at the smallest level, the number of points in that smallest quadrant or smallest tree is less than the maximum number of points for a given block. And in this way, when you're doing particle interactions, you're only doing particle-particle calculations within a block. And you can optimize out the particle interactions outside of those blocks. So with all that said, let's go ahead and try to build this up. And I'm just going to create a very simple, let's start with just the basics. So I'll create a QuadTree.cpp file. Let's print out hello world just to make sure everything is working. Hello world, and in inline, let's try to compile this. And if I, okay, great, no warnings. If I compile it, yes, we have a hello world. Okay, so all that is great. So the best way to create a quad tree is through creating a class. So I will create a quadtree.h file. Let's lock this under a pragma1 so we don't import multiple times. And let's build our class. So we're going to call this a quad tree. It's going to have a mostly all of these parameters should be public, so I'll put everything under the public. This might be a problem later on when you're trying to do inheritance, but for now, we'll just keep it simple and move things later on. The main thing we want to do is have a max number of particles in the tree. And the way that the quad tree works is it has each data structure has access to the children. So we're going to have to actually create 4 substructures for sub objects that are kind of in the top left, top right, bottom left, and bottom right. Let's create this kind of statically right now, and then we'll optimize and try to put this into more standard ways of doing this later on. So I'm going to create a quad tree set of four children, and these are going to be pointers. So top left, top right, bottom left, and bottom right. And then each of these should have access to a bunch of points. So let's create a vector that holds these points, and we'll create that point object quickly. For vector, we need to include the vector, and then let's include a, let's create it first. So let's create a quad point.h file. Yes, let's create this. Let's also log this under pragma once. And this is very simple. It's just going to be a X and Y position. And with that, let's try to import this into our quad tree. So import point.h. Now that should have access to the points. And that's basically the very simple version. And now we need to populate this with methods and so on and so forth. So let's build this out. So QuadTree, And we want to basically, let's allocate the capacity. And we're going to set this to the maximum number of points that we have over here, just so that we have that. And then let's create a insert method, which essentially there's going to be this method will basically put the point into the points array. And the reason we want to have an extra method to do this is because this will actually this will do the check for whether we are at capacity. And if we are, then if we are at capacity, then we need to subdivide the quad tree into the 4 quadrants, and then move all of the points that we currently have into those 4 quadrants before we insert a new point. So let's do the check first if the size of the points is greater than n max minus 1, because if it is, or if the points of size is equal to n max minus 1, because if it is, then we need to subdivide. If not, we can just insert this new point, and I should insert that new point here. And ideally, there should be a pointer to the point. So rather than having this, let's do that, because we probably don't want to create new copies of the points every time we inserted the quad tree. We essentially just want to have references to where these points are, rather than essentially having the quad tree control the nature of the data inside. And so right now we need to build the subdivide function. But before we get there, let's just try to see if this works. So need to subdivide. I need to import my IO stream. And then if not, we'll just say point inserted successfully. And so in our QuadTree.cpp, we're just going to create a very quick QuadTree. So let's include QuadTree, and then just let's loop through. I think I need to set nmax first. So let's just right now brute force nmax to some number 50, and then we can come back to looking at it again. If we do this, just do a very simple point. We need a constructor method for this. Let's do 50 by 50 or something. And then qt.insert, and we're just going to keep inserting this point. It's a pointer. Okay, let's see if this works. Yeah, that should be fine. And so in this case, we should have, what I should probably do is to also have, okay, yeah, let's do this. Let's also print out the number of points that we have. So we want to point number inserted successfully. And we'll just also have the number of points that we have. So points.size. Yeah, it should be fine. Okay, so we are able to insert 0.1 through 49, and then when we try to insert the 50th, it crashes, and we say it says we need to subdivide. Great. Ideally, what we should also do here is, well, we'll keep the warnings on for a while. So ideally, we actually want this to be a Boolean return. So if we do this, then we should be returning true. And if we're actually down here, we should return false. So we should handle all of this over here. So right now, let's just return false here to tell us that this is not implemented yet. But ideally, we should catch whether this is inserted or not. Okay, so assuming that we've inserted everything, what we can actually do is to see where these points are in the QuadTree, right? So for So let's just print out the point number. I should fetch. Okay, really hacky version because I don't want to change that code. And then we want point.x and then point.y. These, again, it's a pointer. Okay, that's all fine. Oh, I forgot a new line. But yeah, that seems to be pretty correct. Yep, there you go. So all of these points are basically the same. We could try to increment them a little bit. We could set them to different numbers. So we could set this to where is static cast defined in? Let me just check quickly. I thought this was in. Oh, I see. This is an IO string. Okay. It is not. I'm just trying to figure out where static cast is defined. That's pretty strange. Unqualified ID. Um, yeah, so I shouldn't actually need IO string here. So point.x should be a double. That's correct. Let's just try to set this to. No, that's still problematic. Is this a static cast? Oh, I see. Okay, so that's my bad. And so we should be able to set point.x to basically that. If you run it, because it's being stored as a pointer, it's setting it to the last value each time. So maybe what we should do is just do this. We'll create a new point each time and then just store it. This shouldn't be the way you should do it, because I'm pretty sure it's being removed each time. Let's just create this in memory. Again, this is probably not the best practice right now, but again, we're just trying to make sure things are working. Yeah. So essentially creating a new pointer each time works. What we should probably do is to have the QuadTree, essentially, rather than storing a bunch of pointers like this, we should create something like a unique pointer or a shared pointer. Maybe you should do it as a unique pointer. And then hold stuff there. But for right now, we're gonna do things pretty brute force, and then we can go back in and change things as we go. Okay, so now we have working points. We're able to add and remove new points. Let's go ahead and try to figure out the subdivide command. So ideally, if we do need to subdivide, it should subdivide first, and the subdivide is not created. So let's create this. So subdivide shouldn't need any arguments. It's just telling you that the QuadTree should subdivide, and each of these should be the subdivided leaf nodes should basically be instantiated. What we probably need first is we should actually have a Boolean check whether this is divided, because if it is divided, then we need to figure out where to insert the new points to. We should basically take the insert function and then pass it into the uh, the leaf nodes. So maybe let's do that first. So if is divided, right? If this tree is already divided, we should actually figure out which quadrant the point should go into. And to do that, we have to figure out what is the bounds of each of these quadtrees, and how do we actually basically what is the spatial location in which the new point should go into. So let's comment these things out, and then we'll start building the data structure. So if it's divided, we should actually never be here, and we'll just return false for now. If not, we need to subdivide, basically instantiate the new leaf nodes. Okay, so what we actually need is a way to create, figure out what the bounds of this QuadTree is. So to do that, let's create a new class. Let's just do practical once again. And this bounds is going to be very simple. It should just have 4 attributes, x, y, or maybe the x min, y min, and then the width and height. Need that. Okay. So then bounds is just going to take in these 4 parameters. And then just initialize them. I like to spell these out just so that it's obvious what's actually happening. My formatter isn't working for some reason, but that's fine. We'll figure that out later on. Okay, so we have our bounds variable, and what we should do is to check whether a point is inbound. So let's just include a point here. And we'll have a how should we do this? Let's just do that. Yeah, and this should be a const point because we don't want to edit it. And essentially, this should just check. This is a very simple check. So if point.x is greater than or equal to x min, and point.x is less than x min plus width, point.y is greater than or equal to y min. Probably what we should do uh, so that things are easier. Let's create an x max and a y max. Then we'll initialize those here. X max equals x min plus width, and y max equals y min plus height. That way we don't have to do all of these. X max, y max. Okay, if so, then we return true. If not, we return false. Great. So does this work? So what we actually should do is to initialize, we need to set this into our QuadTree. So the QuadTree should have always a bounds object. Bounds doesn't have a default constructor. What we should do is also have a bounds that takes in a other bounds and then basically copies it over. I forget. Can you just set this to default? I believe I should just be able to do this. If I do that, I should be able to just take in bounds object and then just initialize private. I see. So these should be public. Yeah, that should work. So in here, I need to define a bounds first. And this should be fine. I mean, I can set this outside. And let's have this be 0, 0 for the bottom, the top, bottom on the left, sorry, and then have a width of 25 by 25, right? And then pass this into our QuadTree. So this should basically set the QuadTree to have a width and height of 25 by 25, starting at 0, 0. So it should be able to insert points that are inside this 25 by 25 box, but you shouldn't be able to add anything that are outside it. So in order to add that conditioning, let's put this here. So essentially, if it's divided, we need to figure out what quadrant this is going into. That comes later. This is if the points are full. But what we should do here up here is if bounds dot is I see. I've basically called that incorrectly. Okay. If not, then we should just return false. The false point that should work. Sorry, that should work. There's a reason we shouldn't be using pointers, but again, we can fix this later on. Let's create an error here and say point at it's outside the bounds. And this needs a new line, and then we just need point x and point y. And just for the sake of clarity, let's change this function. Let's call this contains instead. That makes more sense. So this is just a Boolean that tells you whether this point is contained in this bounds. All right. So now if we run this, it should hopefully not give us any errors. Yes, it doesn't. I should just change this to I forget what the long formatter is. Is it just LD? Yes, LD. Okay. Let's just do LD here so it doesn't give us any errors. And I think also down here. No errors. What are you doing? Subdivide. Control reaches end of non-void function. What is that? The bool subdivide. Okay. Well, we'll just do the same thing. We'll just return false here. And ideally this should be, should we just change this to size? Yeah, let's just do that. That shouldn't give us any. Come on. Let's be complete. LD long int. That's fine. I'm just gonna let that because that's diagnostic anyway. So if I run this, oh, I see. That's probably because all of these are outside the bounds. Okay, let's set this to 20. Well, glad to know that that works, but let's see if we're able to fill some of them. Right, so that is a problem. The point at greater than x-min maybe I'm doing something incorrect with the pointers here. I moved it right. Let's call this out. No, that's correct. Let's be a little more descriptive in our. Yeah, that's all correct. So point at x should be greater than x-min. Maybe x-min is not being set correctly. Against bounds, let's just do min, x max, y min, y max. It might be that, yeah, right. Might be that our constructor is incorrect. So if we set this here, set this to const. Yeah, this is just memory shenanigans. This should be the way you get this to work. Oh, I see. So I have to set this to default. See if that works. Yes, there we go. Cool. I just forgot to set it to default. Okay, so let's remove this. And now we see that these are being set. So points 1 through 25 are inserted successfully, and then from here on out, things are outside the bounds. So it doesn't actually insert these points, and so that's why you see down here, we only have 25 points in the QuadTree. So that's coming from these print functions down here. This print function down here is telling you how many points that we have, and you see that we only have 25 of them. Great. So that means that we're actually able to insert points successfully, and now we can get back to our division function. So now what we need to do is, these are all pointers. So what we should do is basically initialize them. So the top left is going to be a new QuadTree with a bounds that takes in. So let's create our convention here. So the top left is going to be, or let's just say our bottom left is going to be 0, 0, going to width over 2 and height over 2, right? And then that means our bottom right is going from width over 2, 0 to width 0, right? That means that the top left is going from 0 height, yes, height over 2 to 0 height. And then the top right, it's just going to be the last option, which is width over 2 to width height. So these are going to be the 4 quadrants. So in this case, bottom left is, oh, sorry. So let's just do the things in the same order. Bottom left is going to go from x bounds dot x min. I'm not sure what happened to my LSP. It's okay. Y min, and then it's going to be the over 2 and bounds dot height over 2. I'll just return here. Okay, bottom left and then bottom right. It's going to be x min plus bounds. So it's going to be the exact same width and height for all of them. Maybe we should just create a function in there. So const half half height width and half height. And the same thing here. So there's also going to be half width and half height. Okay, so those are the bottom 2. Let's just clone that and set bottom to top. And now instead of this, it's just going to be ymin plus half height. Plus half. Great. So now we have our 4 new QuadTrees that are defined. Um, and that should be it. I'm just checking to see if there's anything else we need. And so we should just say, put this here, return. Well, once we subdivide, we should actually insert the points into the leaf nodes. I'm just trying to think of the easiest and simplest way of doing this. Ideally, we should actually make this an array, and that then we can just loop over the array and then insert the points recursively. So basically, loop over the leaf nodes, insert the point in here, because right now we just have to do bottom left dot insert point, then sorry. Bottom right dot insert point, and so on and so forth, and then figure out if one of them is true. Because alternatively, we can just do, if it was true, we just return true at the end once one of the child nodes has inserted. And actually, I'm just realizing that we probably, yeah, up here we need to just do that first. Well, let's just do brute force for now, see if it works. And then we can optimize it later. So what this is going to do is just actually go through each of these nodes, and then I'm just going to copy this here. The calculation itself is pretty straightforward. All it is doing is just checking. Remember that basically you call this function. Let's make this 100 so we can see the actual division happening. And then this can be some small number. Ideally, this should be a random number, but it should be fine. Let's just do 20 by 20. So what's actually happening is once you call the insert function, it'll first check if it's divided. When you've started the program for the first time, this is not going to be divided, so it's going to skip this, and it's going to check if the point is contained in the bounds. In this case, it's 20 by 20. We're trying to put this in a box of 25 by 25. So this will always return false. So it always does this check. Sorry, it always returns true. So it'll always do this check, and then it goes in here, where initially we're not going to be filled up. We're not going to be at capacity. Maybe I should just change this and call it capacity instead. Probably makes a little more sense. So if we're starting the program for the first time, it's just going to go through this, and we're not going to be at capacity, so it's just going to push back the points, and we're going to get up to 50 because our capacity is 50. We're going to get up to 50 points that are inserted. Once we hit 50 points, it's going to come down here. It's going to hit this capacity number, and we need to subdivide. And once we subdivide, ideally we should actually try to insert the point again. So maybe that's what we do. Maybe we'll just do a recursive insert. Yeah, let's just do that, because once we're subdivided, we should just be able to insert recursively. And what that's going to do is to essentially load up the point, put it into insert, and now that it's subdivided, we should set is divided equals true here. And once we're divided, it'll go in through here and then try to figure out which of these points are actually there. So let's say we're inserting it in the bottom left. It'll go into this, which we'll call this function, but in the leaf node, in the bottom left leaf node, and that'll do the same calculation. Initially, it's going to be it's going to check this. If it's not in the bottom left node, which in this case we're doing 20 by 20, so actually it'll be in the top right node. So the bottom left node will do this calculation. It'll return false, and you'll be back here. The bottom right node will do the same thing. The top left node will do the same thing. Then the top right node will succeed this. It'll not be at capacity, so you don't have to subdivide. And then it's just going to insert the point into the top right node. That means that basically we're going to go through recursively and hierarchically subdividing the QuadTree, and then inserting the point at the right location in that QuadTree. So I think for bookkeeping purposes, it would be nice to see level. So int level over here. And then here we'll also set that level value. Yeah, I don't know what happened to my LSP. I don't know why it crashed. Maybe let me just restart. Yeah, it looks like my LSP just crashed. That's all right. And so in here, we're actually going to increment that level by 1. So that we can just basically print it out here into level, whatever it is. Okay, so ideally if we compile this, there's an issue, and that's probably because, yeah, we need to insert the level here. So there's going to be level 0. Okay, no bounds will be initialized after, that's fine. That's also fine. Okay, cool. So if I run QuadTree, ooh, segmentation fault. Okay, this is a fun one. It's probably in one of these. It's going to create a new QuadTree. Oh, I see. I should set this to false initially. There you go. I don't know why we continue to let's check this out. Okay, so it's probably if divided, we need to just return true here. So it should have inserted into one of these things. Ideally, we should check whether it inserted it. But for now, let's just ignore it. Because if we did insert it to one of the leaf nodes, we should just return and exit out of our main return function. There you go. So it's able to, we created 2 levels actually. So point 1 up to point 49 is inserted successfully. And it subdivided. It ran through the 3 calculations, which is right here, right? Bottom left, bottom right, top left. And then it inserted the point into the top right function correctly at level 1. And then we keep going. It does, point number 2, which at this point is point number 2 for the top right subtree, right? And we keep going down the chain until we hit up here. 9, 10, 11, 12, 13, 14, 16. We hit 50. It needs to subdivide again. And then it does 2 more. I'm actually confused by why it's doing 102. Or sorry, 101. So what we should actually do is once we subdivide, we should move the points that we have from here into the all of the newer points. The subdivided quadtrees. So once the trees are divided, let's create a new function, move points to subtree. And what this should do is to essentially take the points that we currently have and move them down. And so we should never be able to insert into this main tree ever again because we're always going to be divided, right? So once we're divided, it should always insert stuff into a smaller subtree. So let's do that. Let's move points. And so if I remember correctly, there is a way for C++ vector to loop in reverse. I think I should just be able to start from end. Um, yeah, so let's see. This is, I think, how you do it. Okay, I think we're at the point where I need to think really carefully about it, about how we're doing this. So I think I'm going to take a little bit of time to try and move this into a vector structure. The reason for that is I don't just I could essentially copy this over. I could do this over here, and that'll be perfectly fine. It's probably point dot, what was it? Let's see. I think this is that right? Yes, because this is a pointer. Right. So ideally, I should be able to just do this, but I don't want to be in a situation where it inserts multiple of them at once for any sort of like numerical error or bug. Um, and so let's think about how to do this. So I think what I want to do is rather than do this, I want a array of QuadTree of size 4. Let's call this leaves. Initiative. This is an issue because you should ideally have this initialized first, and the easiest way to kind of get around this is to either create a unique pointer. I think I need, where's unique pointer? Is it in C standard library? I think it's in memory. Yes, it is. Or maybe the easiest way to do this is to just create a QuadTree star. Template. Why is that? Wait, let me just look this up. Um, I think this might be because I'm trying to create a sub instance of the same class. I understand this correctly. Um, Let me check. Apparently, one of the things is to include array. Oh, that does remote. Cool. Okay. A little strange. I don't know if I'm able to get. Yeah, I don't think I can do that. Yeah. So I probably want pointers. Can I do unique pointer? Probably the smart way to do things. Yeah, it's probably because I need to include memory. Yeah, that works. So I shouldn't need to do um, all of this stuff. I should just do um, leaf of leaves, and then if leaf dot insert point is breakout, just return true, right? Is equal to delete the constructor. I think I can't do this. I should probably just loop over. Yeah, that way. Um, so basically, you're looping over all of the leaf nodes. If one of them inserts it, you don't have to check the others. Just return true. This way, we make sure that nothing is inserted multiple times. Um, what we can do now is actually, well, so leaves of 0. So basically, we're going to do 0 is the bottom left, 1 is the bottom right, 2 is the top left, and 3 is the top right. Right. Uh, how do you create a unique pointer? Let's look at the reference here. Make unique, right? Make unique. We want to make a QuadTree with those values, and the same thing here. I should make these into enums, but we can do that later on. Okay, let's just do that. So new QuadTree becomes the big unique, like so, and then this is leaves of 2, and this is leaves of 3. Great. And ideally, actually, we should just be able to do this. Insert point, because that should just call the old function, and then we should just be able to point start remove. Forget what the command is. I think I should just be able to do this because we're looping from the back to the front. And that should just automatically pop back the. Let me just check that. Yeah, the pop back should remove the last element from the vector. Basically, we're adding each point. I'm concerned that we're doing this the wrong way. I might have to do our end and our begin and then go backwards. But let's check that out. Okay, our code compiles pretty nicely. And segfault over here, as soon as we try to divide, it's probably because of this. Let's start to figure out what's going on. Moving points. I'm just going to be explicit about this. So basically, I want to loop backwards from size t minus 1 um, until I is equal to 0, right? Okay, that works. We do still have a segfault, but after level 1, which is a little strange. Need to subdivide, moving points. I think what, just to make sure, done moving points. Let's just make sure, because ideally you should be inserting a new point and you should be starting to subdivide only at the end. Let's just try this. So running this out, it's still not done moving points. So we started moving points and we're not done moving points. Points.size -1. Maybe I'm missing that. Level 51. That's completely crazy. It's probably because we're doing everything into the same node. Okay, it's probably time to insert a little bit of randomness here. Or at least let's make this a function. So we're not inserting stuff into the exact same node each time. Or I over 4. Okay, level 2. So 12 by 20 should not do that. Okay, so basically we've inserted the first 50 points into level 0. Works great. So now we subdivide. Um, let's just check this point at point dot x and point y. So we're inserting, there you go. Let's just make this a little bigger. Okay, so these are going to level 0. It starts to subdivide. It checks the bound for the top left and the, no, sorry, bottom left and bottom right, right? Because it's doing moving points. It checks the, basically it's checking this point, yeah. 49, which is 12 and 20. Checks them. It does the 4 different sub-levels, does 2 of them outside the bounds, does the third one successfully, moves on. 11 by 20. Um, I see that, well, that's not really a problem, but that should be a little better. And so now it does things all the way down to 0 by 20. So that should work. Ah, I see. So this is moving from level 1 to level 2. So I'm a little confused why we're back to. Oh, see. So this is moving points from. Okay, let's just make this clear. From level 2. Okay, let's just run this again. Okay, so we were here. We've inserted the points moving from level 0 to level 1. It's done moving points. All of these are continuing to add to level 1. Eventually, this will hit 49, moving points from level 1 to level 2, 24.5. Right here, 24.5. I wonder if. No, that's correct. So if it's divided, it should go into the sublevels, and then it should check if the point is contained. If the point is contained, it does all of this, right? So in this case, um, now it's just going to take all of these points and move them to level 2, which is correct, and it should run them down till. I see. Okay, so it goes down to here, and then now you're moving to another subgrid. Okay, so now it does 3. So this is bottom left, bottom right, top left, does the top right, which is correct. And now we've shifted so that we're now doing top left. Okay, it keeps going. Great. So now the issue is it's done moving points. question is, why do we not insert the very last point? So this is correct. I should have done greater than or equal to 0. That is the right way to do it. But it does give me a segmentation fault at the very end, which is a little strange. So that should be point number 1, or point really number 0, because this is plus plus. I believe I'm doing a plus plus. Yeah, it's doing points dot size. Um, moving point. No, I do have a stream. What am I doing? I see. That should be fine. Okay, so it got through the end. So I see that it's inserted, and I think it's the pop back that's really having an issue. I could make this easy and just, I could reset the points, but I want to figure out why this is having an issue. Um, let's just say here there are, well, let's be right about it. Um, oh, I see. So that works. So why am I not getting the? Right, but the issue here is doesn't actually work. If I do this, 0 items left. That is correct. It should be down here. So why is it going to continue trying to do this? Yeah, see, it's gone back to. It probably is because it's being set again. Being recalculated here. In items. I could be smart about this and just say it's the n max, but let's do that so it's constant. Still not right. Um, Not sure that that's the right way to do it. Yeah, right. That's not the right way to do it. So this should only get us to, yeah, 1. So we do need to still do 0. The question is, why is it looping again at the start? Um, let me just look this up really quickly. There's an empty function. Okay, so I could do this while not points dot empty. I could always fetch the back. Um, oh, let's do this. Points dot back. So this kind of keep things self-contained. Yeah, there you go. 0 items left. This is a little troublesome. I'm not sure why we're not seeing any bounds, any insertions happening. Maybe my half width, half heights are incorrect. Okay, what I'm gonna do is when we create a new QuadTree, I just want to put out this structure here. So that's going to be x min, x max, and then y min, y max. So that's going to be bounds dot x min, bounds dot x max, bounds dot y min, and then bounds dot y max. All right, let's try that out. Let's make sure that the new quad trees are being okay. Let's just remove all of these print functions. This one, this one. We know this is working. We know this is working. So we don't need this anymore. Okay, so first we create 25 by 25, and then it's going to create 12.5 by 12.5 over here. So this is wrong because it should create 0, 6. Oh, I see. Is that correct? Not so sure. Let's print the level just to make sure things are correct. Um, and then here, let's just say subdividing with these bounds at this level. Okay, cool. Subdividing this quad tree, we get these 4. That's correct. So this is bottom left. This is bottom right. This is top left, and then this is top right. Great. So now it is subdividing the top left, which is this one, right? So that should do 0 to 6.25, and then 12.5 to 18.75. That's correct. And then 6.25 to 12.5, then 12.5 to 18.75. Yes, this is all correct, actually. That does make sense. The question is, you are doing that. Why are you having Okay, let's see what's going on. Okay, 0.020. The question is, why is it trying to insert it there? Let's also print the positives to make sure they are inserted. So we know there's a few. Oh, it's too many. Just separate everything by a new line every time we insert a new point. Okay, so every new line should be when we're trying to insert a new point. So it's trying to insert it into. Okay, I think there is some shenanigans happening with the divided. I prefer fprintf. It's just muscle memory. So let me try to use printf instead. Trying out sublevel. It's just a temporary message. Let's just put this here. Inserting. Okay, so this should be at the max level. I think what might be happening. Okay, so you insert it. I think this should be return false. That's probably what's going on. Yeah, that's the issue. There you go. So the problem was this was returning true, which would take this to be returning true, and so it would never try out a new node. But ideally, you should say if you're going down recursively through the tree and all four of your quadrants do not work, that means that you should try a sibling leaf essentially. And so that works. Cool. So now we have a quad tree. We have something that we're able to insert points into. Um, I'm going to remove all of these and then actually print out what our final quad tree structure looks like. Um, 13 point. Okay. Okay. I'm going to create a print points method so that we can just recursively go through the tree. And if is divided, what I'm going to do is for can I do this? No, I can't. Okay. And then here, which is going to say this is going to be point. point y, and then the level of this QuadTree. Okay, so this should work. It's trying to do insert points. Okay, I need to call the print points function. There we go. So here are all of our points. So all of these points are now in level 2, because the QuadTree has been subdivided in such a way that you actually cannot hold as many points as you want. So I'm going to stop here. I think it might be useful to actually try and implement a GUI so we can plot out these points. But for now, our QuadTree structure works. We're able to insert points into it. And we have a data frame that's able to host all of this information. So the next step is to actually add more functionality where, for example, you want these points to be a little more dynamic. So if you move these points in and out, maybe from frame to frame or something, the QuadTree should update that structure. It should figure out which point is still within the QuadTree. If not, it should move it to a next or neighboring node as needed. And let's also add a GUI so that we can actually plot these out. All right, so until then, see you around.